Hi, welcome to Dissolve Chemistry. So let us start with new topic, that is haloalkanes and haloarenes. Okay, so in that first we will see introduction, classification, nomenclature in this video, and we will continue with the preparation all in the upcoming videos. Okay, so let us start with the introduction to haloalkanes and haloarenes. So when you replace one or more hydrogen from alkanes with halo groups from alkanes or on aromatic compounds, so then the resulting compounds are called as haloalkanes and haloarenes respectively. Okay, so if I replace, say for example, you can take CH3, so it is ethane, alkane. So now if I replace one or more hydrogen, one hydrogen we will replace with halo group like chlorine. So then the resulting compound CH3CH2Cl, it is called what? Chloroethane. Okay, and it is an example of your haloalkane. Similarly, now suppose if you replace one of the hydrogen atom on the benzene ring, one or more hydrogen atom, say for example bromine, so the resulting compound is called bromobenzene and it is referred as what? Haloarenes. Okay, so this is what is haloalkane and haloarenes. So now these haloalkanes and haloarenes are a very important class of compounds, reactive intermediates in the industries. Okay, and as well as some of the compounds play very important role as pesticides, fungicides, and all that. And some are like chloromophenicol. If you take, it is used as antibiotic. And there are many halo compounds are there, polyhalogenated derivatives are there, which are being used as refrigerant, like freons, what we call. And apart from that, they are also used as anesthetics. We will go in detail with this haloalkanes and haloarenes. So first we will start with the classification of haloalkanes and haloarenes. So classification of this haloalkanes and haloarenes is based on two classifications we do. One is based on number of halo groups present. Okay, we do one type of classification, and another type of classification is based on the position of halo group on either sp3 carbon of the organic substrate or sp2 carbon. Okay, so let us start with based on number of halo groups. See that one. So one is called monohalogen derivatives. So when the carbon substrate is being attached with only one halo group, then they are called as what? Monohalogen derivatives. Examples you can see. Say for example, you can take CH3CH2Cl, chloroethane, or you can take CH3Cl, so then chloromethane, or you can take a haloarene as an example, chlorobenzene you can take. Okay, so when only one halo group is there, then they are called as a monohalogen derivative. So the next is dihalogen derivative. When two hydrogen atoms were being replaced with two halo groups, or when two halo groups are present in the given organic compounds, then it is called what? Dihalogen derivatives. And here again we are categorizing them into two types. One is called geminal dihalides and another one we call it as what? Vicinal dihalides. Geminal dihalide means both the halo groups, okay, CH3, CH, Cl2, one dichloroethane. Okay, both the halogen or both the chlorine atoms are on the same carbon atom, then they are called geminal dihalides. Vicinal dihalides means when halo group is present on the two neighboring carbon atoms, then they are called as what? Vicinal dihalides. 1,2-dichloroethane is an example. Okay, next we will move on to trihalogen derivatives. When three halo groups are present in the organic compound, then they are called as trihalogen derivatives. You can take example as very important and common example is chloroform. Okay, trichloromethane, what we call. And you can take a 2,4 Okay, trichlorobenzene we will take. Okay, so this is example of a haloarene which is having three halo groups. Okay, so similarly next is we call it as what, more than this we call it as polyhalogen derivatives. Carbon tetrachloride is one of the example, and hexachlorobenzene is another example where more than three halo groups are present. We call it as what, polyhalogen derivatives. Okay, so this is how we are going to classify based on number of halo groups present in the organic compounds into various class of compounds, right? So next we will move on to which carbon atom the halo group is attached. We are categorizing them into two. One is called as halo group on sp3 hybrid carbon atom, halo group present on sp2 hybrid carbon atom. So into various classes. Okay, let us take the examples. So one is your haloalkanes. Okay, example you can take, say for example CH3 CH2Cl. Okay, here halo group is present on the carbon atom which is sp3 hybridized. Okay, so our second class of compound we will take it as allyl halides. First we will understand what is allyl group. See here, carbon carbon double bond. Okay, so then next carbon CH3. Okay, we call it as what, allyl group or allyl carbon we call this. The carbon atom which is directly attached to doubly bonded carbon is called allyl carbon, and you see its hybridization is sp3 and it is attached to sp2 carbon atom. Okay, and if one or more hydrogen atom if I replace with halo group, so then they are called as what, allyl halide, and it is also one of the example of halo compounds containing halo group on the sp2 hybrid carbon atom. And third one is, so haloalkanes, allyl halides, and next one is benzyl halides. Now say for example you take toluene is there. In toluene, all the carbon atoms on the benzene ring are sp2 hybridized, whereas this methyl group which is attached to that, it is sp3 hybrid carbon. Now if I replace one or more hydrogen atoms from this with X group, so then they are called as what, benzyl halides, and these benzyl halides are also once again the class of what, halo group attached sp3 hybrid carbon atom. Okay, so let us move on to next the halo compounds containing halo group on the sp2 hybrid carbon atom. So that is, we will take example as, the first one is, we will take vinyl halides. Okay, so we can take example as vinyl chloride or vinyl bromide. So when the halo group is directly attached to sp2 hybrid carbon, okay, so like chloroethene is an example, or we call it as what, vinyl chloride. So this is one of the important compound of a class called sp2 hybrid carbon atom, halo compounds containing halo group on sp2 hybrid carbon, we call it as what, vinyl halide. Similarly next one is aryl halides or haloarenes we call. Second one is haloarenes. So in benzene we know that, okay, all the carbon atoms are sp2 hybridized. Now if halo group is present on such carbon atoms, okay, so they also come under the category of containing halo group on sp2 hybrid carbon atoms. Okay, so this is how we are going to classify haloalkanes and haloarenes, okay, into various class of compounds based on the position of the halo group and number of the halogen groups. Okay, so let us move on to next nomenclature. So the nomenclature we do, first we will take a haloalkanes. Okay, how they are being named, haloalkanes. Okay, so they are being named as in trivial system or common names, what we call trivial name. So they are named as alkyl halide. Okay. Whereas IUPAC names named as halo first followed by alkane, respective alkane we are going to name. So alkyl halide. Say for example, we will take simple example CS3Cl. We call it as what? First we will call it as alkyl group, that is methyl chloride. Similarly, the same compound is named as what? Chloromethane. Okay. And next example you can take CS3CHCl CS3. Okay. So we call it as what? Isopropyl chloride. And it is named as what? 2-chloropropane. Okay. We have to assign the position to the halo group, okay, according to the rules, and then we should specify the number or the position. Okay, then we have to name halo, then followed by alkane in the IUPAC name. Okay, similarly we will take another example, CH3 CH, okay, ClCS2 CS3. So we call it as what? Isobutyl chloride we call, and the same we name it as what? 2-chlorobutane. Okay, so this is how we are going to name monohalogen derivatives. Similarly, we will see haloarenes, how they are being named. Generally, in haloarenes, naming the haloarenes, IUPAC names and common names will be same. Okay, in most of the cases. So we will see that. Okay, so we call it as what? Chlorobenzene. Okay, similarly, you can take 1,3-dichlorobenzene. And you can take another example as CS3Cl. Let us assign the position of the halo group with respect to methyl group. So therefore we call it as what? 2-chlorotoluene. Okay. So this is how we are going to give the names of haloalkanes and haloarenes. Okay. In the upcoming video, we will discuss regarding preparations and underlying chemistry of each preparation we will go, so that it will be very helpful for your entrance examinations. Okay. Thank you for watching, and please don't forget to subscribe our channel.